The second reason why it is difficult to understand assembly instruction is that you need to understand additional features in RISC-V architecture. In this lecture, I'm going to talk about this topic. Let's assume that you have understand the syntax of each individual assembly instruction. And take for example, you understand add assembly instruction, SD assembly instruction, and then you can understand syntax of MV assembly instruction. And then when you look at this instruction, then you will realize that, oh, this instruction support addition operation. And first operand is to add it to the second operand. And result of this assembly instruction is stored in the destination register. In this assembly instruction, the destination register is SP register. And if you examine this assembly instruction, and you will analyze this instruction in the same manner. But another important thing you have to understand when you examine assembly instruction is to understand calling convention in the RISC-V architecture. So if you analyze this instruction from another perspective, I can say that the reason why this instruction is performed is to move to the stack frame to have the stack spaces to store the temporal data in the function. So every assembly instruction that is started is the SP, the add assembly instruction with stack pointer registers, because in each function, the first task should perform is to move to another stack frame based on calling convention. So if you look at this instruction from another way, it is activity to have the specific stack frame in the function, in the stack frame, and the data in the local variable can be stored into the stack frame. And this instruction can be analyzed in this manner. And I'm going to look at another assembly instruction, that is move assembly instruction. When running this instruction, the value in the A1 register is copied into S0 register. As for this instruction, value in the A0 register is copied into the S1 register. So why this instruction is performed? So this is the important question every time you are analyzing the assembly instruction. So when the function is called, usually argument like x and y in this example code is passed. Based on calling convention in the RISC-V architecture, the first parameter is passed using the A0 registers in RISC-V architecture, and second parameter is passed using the A1 registers. So if you look at the assembly routine from this perspective, based on calling convention in the RISC-V architecture, I can say that, oh, this operation is to store the parameter passed to this function. And then if you analyze this instruction, and you will perform the addition operation between two values with S value in S1 register and value in S0 register. But what happened before this instruction in this function is that value in A1 register is copied to S0 register. In case of this instruction, the value in A0 register is already copied to S1 registers. So when running this instruction, addition operation is performed the two operand. So like first operand is S1 register and second operand is S0 register. So this instruction is corresponding to this statement in C program. So I think additional features like calling convention, and another important features in RISC-V architecture so need to be studied to understand. So assembly instruction routine in RISC-V architecture. That is the message. That is the message I want to deliver. And another thing we have to remember is that so when running this assembly instruction, and you can analyze this instruction that some data in the stack area is loaded into the RA registers, and then running this instruction and program counter will be branched into the address in the return address register. And if you look at this assembly routine from another perspective, then this register, the return address registers, is already pushed into the stack space in the process, because please take a look at this. And when running this instruction, the value in the return address is pushed into the stack space. So what this instruction does is to perform the pop operation, is to retrieve the data from the stack space in the process. So when running this instruction, it will go back to the address that called this function. So every time you are in the situation to analyze assembly instruction, and I think that you are recommended to look at the assembly instruction from various perspectives. In many ways, understanding of calling convention in the RISC-V architecture is necessary, is most important things to remember. And another instruction or background knowledge that is required to understand assembly instruction is the exception and software generating exception, and also understanding of registers, including general pop-up register and control status register is required. So if you only understand syntax of assembly instruction, that is not enough. So in order to understand the assembly routine in the real project, we need to understand additional features in RISC-V architecture. I can say that this could be another challenges for the entry-level system software engineer. Don't worry if you are in this situation. I'm here to support you. I'm going to analyze assembly routine from various perspectives. Just sometimes I will analyze assembly routine based on current convention. Sometimes I will examine assembly routine from the perspective of exception handling in RISC-V architecture. Now that we have discussed about challenges to run the assembly instruction for beginner, the next lecture I'm going to talk about what can be done using assembly instruction in the real project.